Hello and welcome everybody to our next episode of the Big Data and Biomedicine Seminar Series, brought to you by the Precision Medicine Lab. These are 40-minute talks by eminent speakers and visiting academics in areas of their expertise within and at the interfaces of biomedicine and big data. Before introducing our speaker for today, I'd like to take a couple of minutes to share some very recent updates from our lab. First of all, warmest congratulations to our RAs Hamad Iqbal and Shagufta Rehmat for winning Best Poster Awards at the ISMB 2021 conference organized by the International Society for Computational Biologists. Well done, guys. Two PML startups, CalKitna and GlucoBuddy, have gotten cash injections to speed up their prototyping. Congratulations to both teams. Digital health is finally finding a home here in Phase 5 Peshawar. We recently bid farewell to some of the most brightest high school summer interns that we've had at our lab. They completed a 6-week internship and are on their way out to college applications now during their summer vacations. The lab also organized the PML Hacks 1K Innovation Challenge at the Rahman College of Nursing. It drew a lot of interest, and students pitched their ideas and won on-spot cash prizes. PML Hacks program engages passionate community members to come forward and play their part in revolutionizing healthcare in Pakistan. There's a lot more going on, so please stay tuned to on our website and our social media for announcements. Lastly, I would also like to take this opportunity to welcome on board our new RAs who have recently joined us. All the best to you guys. Make the most of your time here. Now, our speaker for today is Dr. Muhammad Salman Khan. Dr. Salman Khan is an assistant professor at the Electrical Engineering Department at UET Peshawar. He is also the principal investigator of AI in healthcare and the Intelligent Processing Lab, which is part of the National Center of Artificial Intelligence. Dr. Salman is also a member of the World Health Organization's roster of experts on digital health, and recently he has founded a smart digital stethoscope company called the USTETH. I would encourage all the audience to ask any questions that they'd like in the comment section, and we'll be happy to take them at the end of our talk. So today, Dr. Salman will be talking about the applications of medical AI in research. So welcome, Dr. Salman.
Walaikum Assalam. Thank you very much, Ji. Thank you, Shahram.
Hope you're well today. Thank you very much for joining us and playing a part in our efforts to highlight the cutting-edge scientific work that's going around us in Peshawar, in KP, and in Pakistan. So without much delay, I'd invite you to please share your screen so you can enlighten our research group and other community members of your work.
Okay, just give me a few seconds.
Sure. Before Dr. Salman gets back to us, so he's recently, like I said, founded the USTETH, which is a smart digital stethoscope company. Maybe he can talk a little about it towards the end as well, because we're very excited to see products coming out of scientific research. So please, Dr. Salman.
So I hope my screen is visible to the participants.
Yes, should be fine. Great.
So am I audible also? Am I audible to you and other participants?
Yes, we can hear you fine. Yes, okay. We can hear you fine. Thank you.
So, Bismillah ar-Rahman ar-Rahim. Good afternoon, everybody. So I'll be talking about medical artificial intelligence research today, this afternoon. I currently am affiliated with the University of Engineering and Technology, Peshawar. I'll just quickly brief you about the university, and I'm also associated with the artificial intelligence in healthcare lab within the Intelligent Information Processing group of the National Center of Artificial Intelligence at UET Peshawar. I'll also briefly talk about NCAI. My research interests are within signal analysis, signal processing, pattern classification, and artificial intelligence. Currently, some of the active projects on which we are working on include AI in healthcare under the National Center of Artificial Intelligence. We recently got an approval for the HPC and Peridot, which is basically a Pakistan-France collaboration, where we are going to explore and investigate explainable AI models for basically radiologist-informed robust deep learning models to detect some lung diseases for rapid screening using X-ray images. So all these projects, we also currently got some funding together with Khyber Medical University Peshawar to work on some in terms of research directions in relation to oral squamous cell carcinoma, so oral cancer. So we're going to do some uh, AI within genome analysis as well as some pathology images data together with the KMU team. We also have some co investigation going on in terms of with NUST Islamabad and UET Lahore. So UET, where I'm based, I'm assistant professor within the electrical engineering department, is a very prestigious uh, and very old in terms of provincial institution of higher learning. It was a college in 1952 and later upgraded to a university in 1980. It has multiple campuses across the province. So we've got departments over a number of conventional departments, including electrical, mechanical, civil, but we also have in terms of some more specialized areas such as mining engineering, chemical engineering, agricultural engineering, and so on. We have within UET, we have an ORIC, which is the Office for Research, Innovation, and Commercialization, and it facilitates researchers and external organizations in linkages with national and international organizations. There are multiple projects, over 10 billion plus projects actually initiated or ongoing within UET Peshawar under different sponsorship and funding programs, including the higher education from the Higher Education Commission of Pakistan. There are also centers of excellence based at UET Peshawar, including the National Center of Artificial Intelligence, the National Center for Big Data and Cloud Computing, National Center for Robotics and Automation and Cybersecurity. I'm also part of and the PI of an initiative where we are trying to, do some innovation within healthcare, including artificial intelligence. So our lab is funded by the National Center of AI. The National Center of AI, or NCAI, is a 1.6 billion rupees project for 3 years from the government of Pakistan and supervised and monitored by the Higher Education Commission, where there are 9 labs in 6 universities of Pakistan, and we've got 2 labs based at UET Peshawar, including the lab where we are focusing on AI and healthcare. It is Intelligent Information Processing Lab. I'll just jump into the discussion that we're going to hold today. I'll talk about the need for AI in healthcare. I'll then relate this with some studies, scientific studies that are published, some news that has come around the world. Uh, I'll also then talk about in terms of how much and that the governments they're spending and they're focusing on in adapting to this transformation within healthcare uh, by the different countries and governments around the world. I'll then start focusing on the research that we are conducting over the last, that we have conducted and still conducting over the last many years within our lab. I'll then individually talk about and briefly go through some of the work that we've done together with our researchers, including masters and PhD researchers within cardiology, AI in radiology, and then hematology, and some other areas where we develop systems to assist humans in for example, detecting falls, and also uh, some methods that could be potentially used within the hearing aid devices so that humans can, with listening difficulties, can listen as normal people. I'll then conclude my talk. So, according to the World Economic Forum, these are the technologies being currently being leveraged in health and healthcare, and they include artificial intelligence, big data and cloud computing or analytics, and also virtual and augmented reality, nanotech, and autonomous machines, modern machines. So AI and big data are are important contributors within this. There is also a lot of evidence uh, in terms of specifically talking about the need for AI. So these are some important contributing factors that specialist doctors, they're very few in number. You take statistics from every country, developed or underdeveloped, you find specialized cardiologists, radiologists, and other specialists. They're very few in number in terms of in relation to the total population of that locality, area, or country. So the healthcare system becomes overburdened. This ratio is low, and these specialists are overburdened, and also most of the time the clinical decision making in terms of the complex and the huge amount of data that the patient presents becomes complex. So the decision making most of the time is complex, and also there is huge amount of volume of data that is not properly utilized. And if you look at the Pakistani system, so still in terms of in many primary to tertiary care facilities, healthcare facilities, a lot of data is in the form of manual handwritten notes or prescriptions, and there are no proper electronic health or medical health records of people. So this makes very interesting, and in terms of a foundation for the need for this transformation within healthcare and development of tools and employing artificial intelligence in multiple scenarios. I'll quickly go through some of the published studies and some news from around the world that I have personally in terms of come across in these when they were published online in terms of from these sources. So for example, there was news where a study was cited, a US study where it was mentioned that AI is doing a better job in diagnosing lung cancer, for example. And then in another study, there was evidence where AI could, identify skin cancer from photographs with the same accuracy as trained doctors. So, elsewhere it was mentioned that AI outperforms doctors diagnosing breast cancer. And also, when the COVID pandemic started, so there was plenty of funding uh, pumped into multiple solutions for treating, preventing, and managing the COVID-19 uh, virus in terms of. So there was I'll talk about some work that we've done also, but in terms of for COVID also there are a lot of solutions that were proposed. And then, so one study suggests that Google's AI spots cancer better than human specialist doctors. So, so these are some example studies. And then, based on this evidence, the scientific work and the evidence and the findings shared by the scientific research community, governments started to put in a lot of money. For example, the UK government in 2019, uh, they decided to put in terms of 250 million pounds for AI in healthcare. So they've put this money into NHS and the different uh, departments of the National Health Service in optimizing, in utilizing these technologies. Uh, the
Professor
NIH
Mark, sorry,
also.
the slides aren't being moved. I know you've shared your screen, but the slides aren't changing. Can you?
Yeah, so I can, let me go
Yeah,
again. So is this slide visible now?
yeah, it's visible now. It's changing now.
Uh,
Thank you.
Okay, so let me ask you again. For example, if I go to the full screen mode, can you still see the slides changing?
Can you change, please? No, We can't.
Yes, so the full screen mode has issues maybe. So what I'll do, I'll maybe, uh, what I can do is possibly uh, increase the size here and then, just
Okay, yeah,
try to
this works.
improvise. So can you see it changing now?
Yes, it's good now. Great.
Okay, so I talked about in terms of some studies, some published studies that suggested, and then I also mentioned that this evidence, led to governments deciding to put in and pump in taxpayer money into developing their, health systems and further enhancing the processes uh, within their health services and healthcare. So, for example, as I mentioned, the UK government put in uh, around 250 million pounds into their NHS in different departments. And then NIH, for example, this publication mentions that they put in millions of dollars into COVID testing and surveillance, and they employed AI solutions. So now, what are the potential use cases for AI in healthcare? So we can deploy AI in terms of in diagnostics, for example, in medical image recognitions, within symptom checkers, decision support systems, then in knowledge generation, for example, pattern classification or recognition, and then getting greater insights into rare diseases. Also, in terms of within public health, epidemiology, but the digital, aspects of it, and then national or provincial, for example, screening programs. Uh, you could also optimize the system efficiency with, innovative and enhanced care pathways. Also, the staffing requirements for certain tasks, and then, personalized treatments, preventive advice, as well as in prediction of diseases. Some examples and use cases of AI in healthcare. I'll now move on to, in terms of, for the last few years, we've also, uh, uh, researched the published work within the different areas that I talked about, for example, in medical images and, radiology, cardiology, hematology, pathology, etc. So we also explored and investigated some of these problems within these specialities. And I'll now talk about the work that we've conducted. So this is some of the work that we're doing, and we've published some of our results internationally as well. I'll now move on to these individual areas, talking about the work that we've done in radiology, cardiology, etc. So, for instance, within radiology, we have and we are still doing some work on liver cancer detection. So specifically, it's liver segmentation and also liver tumor segmentation from CT, computer tomography images. We also published some work in collaboration with some other international centers for COVID detection using X-ray images, and then we also researched uh, a certain, aspect of brain tumor segmentation. Specifically, it was a brain MRI image enhancement. So, together with a PhD student, Sidra Gul, and master's researcher Islam and Asima, we are investigating AI-based solutions to basically segment, that is, to separate liver from CT volume, and then also segment the liver tumor or the liver cancer from the same uh, volume. So we have, Pakistan is one of the unfortunate countries where, because of the hepatitis B and C, liver cancer is very prevalent, and I think it is one of the, in terms of the top countries within the region, including China as well as China, where this prevalence is very very high, and it's alarming. So we proposed screening the hepatitis B and C positive patients, and then doing ultrasound tests for the patients, and then also, together with radiologists, uh, try to screen the HCC positive, and then the suspected ones to be confirmed using a CT scan. So we want to develop AI-based, solutions on the ultrasound imagery that we develop, as well as on the CT imagery that we, in terms of develop together with the radiologists and sonologists. This would lead to, in terms of programs where a population screening could be conducted. Uh, so we I just briefly skimmed through this area of research that we are currently working on, highlighting some of the results that we have in terms of recently uh, found and published. So we are focusing on liver segmentation because liver is also, the contrast is quite similar to its nearby organs. So uh, the initial technical problem within the literature is separating the liver from other organs as well. So automatically segmenting the liver is the first problem, and then you go into further segmenting the tumor within the liver. And then, so we started off with enhancing the CT volumes. So we investigated some pre-processing schemes where the CT, the computed tomography volumes, are enhanced so that they aid in the proceeding stages where the liver is segmented and then the tumors are segmented. So we recently published uh, a conference paper. It was in the first quarter of this year, where we evaluated and proposed pre-processing techniques using some deep learning models for automatic liver segmentation. So, yeah, the second, within radiology, the second direction where we contributed together with a team, international team from Qatar University and University of Dhaka in Bangladesh, and also collaborators in Malaysia. So we worked on, when the pandemic started. We there was some, because the PCR is one way of testing for COVID. Uh, there was a need to screen in terms of population at different, for example, in scenarios where at airports, or population screening for different offices, government sector offices, and so on. So there was a need to quickly detect whether the person has COVID or not. So there were significant efforts from research community around the world where they explored the X-ray images, and they developed new methodologies and pipelines to detect COVID using X-ray images. So the data that was available, this was early last year, when we worked and developed this data set that was available, publicly available at that time, from different research labs together with hospitals around the world. And we applied and developed some new pipelines where we applied some robust deep learning models to classify whether the X-rays are from a normal patient or a COVID pneumonia or viral pneumonia. So the results were very encouraging, and this system, proved to be a very good foundation for research work, and also development work and deployment in terms of real-time deployment for such systems at for screening a large amount of, in terms of population, uh, for COVID-19 through X-ray images. It was cheaper and it is instant. So some of this work was published last year in some prestigious journals, and interestingly, one of this work was also cited over 300 times in the last year or so. Uh, so we've now started to, we have a master's researcher who is working on some new pipelines for the same, and we've started to work with starting from this year, we started to work with developing explainable models of AI models that we can, that are radiologist informed for the same problem, together with a team of France and Spain. Yeah, so this is something that we worked on last year together with researchers. Fazullah was a master's researcher who focused on in terms of brain tumor segmentation from MRI images, but specifically uh, investigating new enhancement or signal image processing methods where uh, they could, improve the quality or enhance the quality of the MRI image, so that the following stages of tumor segmentation, you know, prove to be more fruitful in terms of better identification and segmentation of the tumor. So these are some of the pipelines. So this study, this study found that uh, Gibbs Gibbs ringing artifact, for example, this is a type of noise. So removing this artifact together with a bias field correction, they were most effective in enhancing the quality of the image, where when tumor segmentation methodologies are applied, they provide more enhanced results. So these are very interesting findings. We got some in terms of fine results as well. So these are currently in review in a journal. Moving on to the work that we are doing and we've done in cardiology, AI and cardiology. So we started off around 2.5, 3 years ago with developing AI-based models where they could be deployed within decision support systems to detect uh, heart abnormalities through the auscultation sounds, through the sounds. And the heart sounds, they're also the graphic record of them is called the phonocardiogram, the PCG. So these sounds are obtained using a stethoscope, and of course a digital one where you can store and process them using a computer. So this work we did together with Faik Jahan, who's a master's researcher, Kareem was also a master's researcher. We developed multiple pipelines for this problem, where we started off by working on publicly available data set. For instance, this one specific paper that we recently published uh, together with the researchers that I mentioned, and also with in collaboration with a, a team of Turkish researchers as well as this researchers from Qatar University. So we work on Physionet and Pascal datasets. These are widely used phonocardiogram based datasets. We developed some methodologies where we applied some transfer learning and also some deep learning architectures, multiple methodologies and models. Uh, and this transfer learning provided an advantage over, individual models if they're trained on these individual data sets. So, so in terms of we last year we published our findings where we investigated both segmented phonocardiograms, that is when experts, for example cardiologists, they label those fundamental heart sounds, the S1 and the S2, and of course the abnormalities S3 and S4. These are the fundamental heart sounds and the systolic and diastolic murmurs, the abnormal sounds. So we applied these methodologies to segmented data as well as unsegmented, where we do end to end. We learn the models end to end, and you just input, uh, a series of time series phonocardiogram signals, the heart sound data, and you get the classification outcome whether they are normal or abnormal. So currently we're focusing on the screening aspect where we do binary classification of the normal and abnormal heart sounds. We recently, last month, we got our article published within the same journal where we published last year, physiological measurement, where we, as I mentioned earlier in the previous two slides, where we developed deep learning methodologies, where we used and exploited transfer learning from, by learning from the different data sets, where the different data sets are acquired using different uh, sensors, and there is variability in the clinical settings where the data is acquired, and also the hardware from which the data is acquired. So this, the transfer learning really exploits in terms of and adds to enhancing the robustness of the deep learning models, and the imbalance in terms of and also variability between different data sets. So we are also now in the process of doing the same with some some clinical studies that we've just started recently with local clinics and hospitals. We are going to explore also the possibility of real-time uh, decision support for the same type of data. I'll talk about some work that we did in terms of within hematology, and specifically, it is automatic image-based thalassemia detection and screening. We, together with some hematologists from Khyber Medical University, including Dr. Yasir, and also some in terms of doctors from local hospitals, including Lady Reading Hospital and Hayatabad Medical Complex, Peshawar, we, we started off by working on uh, hemoglobin electrophoresis blood test, which basically assists hematologists in detecting or diagnosing thalassemia, beta thalassemia, uh, and also if a person is a major or a minor or a carrier, for example. It also, in terms of diagnosis of sickle cell disease and some other hemoglobinopathies. So thalassemia is an inherited blood-related disorder, and it could be, it could be it could be preventive if these, the marriages in terms of between carriers are avoided, and also as for example, if both the husband and wife they're carriers, one of their genes is abnormal, they have a 25% probability of in terms of giving birth to a thalassemia major child each time, child is born. So so our focus basically initially was developing decision support system where the input is the hemoglobin electrophoresis test result. So the blood test uh, gives, the outcome of the electrophoresis test is an image that you can see on the top left, where you get these bands uh, that result from the process of electrophoresis. The blood samples are put on a piece of paper, cellulose acetate in a solution, and they're exposed to, in terms of voltage is applied, and the hemoglobin being a charged particle, it travels towards the opposite charge, and you find at the end of the test you get a band like this, depending on how big the particles are and how they move across, the different pores of the paper. Such bands give hematologists an insight into the abnormalities within the hemoglobin. Now uh, this image is assessed by hematologists, and they're very few in number. So we wanted to develop an AI-based decision support system where we could automatically uh, report on and give an opinion on whether the patient has thalassemia or not. So we developed some methodologies, and there were many challenges because this was real data. There were, the quality of data was very bad. We had to discard images, and there was a lot of pre-processing involved, and also, uh, so in the end, we were able to, get some interesting results where we get a very high sensitivity of classifying thalassemia or non-thalassemia, with a over 95% sensitivity. Currently, this article is in review in a journal. We later on we also developed a prototype where we can conduct the HB electrophoresis test. We got some initial lab testing results, very encouraging results. We have now moved on to some doing some clinical trials of the device, where the entire system is, it's integrated. So you've got the blood test device as well as a system which is basically a decision support system that reports on that the outcome of the test, blood test result. So we've it is a product now for, in terms of which is going through clinical trials, and hopefully it will be a good contribution to be able to prevent thalassemia from to eliminate it from our country. We also have done some work on human fall detection systems, and some of this work I did during my PhD in the UK, where one of the collaborators, Dr. Miao Yu, he's still collaborating on the topic, and one of the master's researcher here at our lab, Rabia Hasib, she together with Kaleem, uh, we worked on the data that we got from the UK, where we want to develop automatic methods which are computer vision based to detect human falls and improve the accuracy of the existing published work. So these are some of the components you want to extract the human from the video or the images, and then classify human postures, and then distinguish a fall from other postures. So this is in terms of the flow of the algorithm, where the input frames, for example, the video, you get still images or frames from the video, and then you extract the humans out of the image. You extract features, and then you recognize the different activities from the humans that are there within the image, and you classify them into the different postures, and then detect whether a fall has occurred or not. So there are different uh, uh, technical in terms of pipelines or methodologies that we explored within the background subtraction part, which is the pre-processing part, where you extract the human, and then also some deep learning based methodologies for classification of different postures and whether fall has occurred or not. So some of the results that we got, we published them early this year. Uh, so Rabia Hasib was leading this. She was a master's researcher. So we published them in local in terms of it was an IEEE conference, but it was organized in MAST IEEE conference on AI. This was an international conference. The paper is available online on IEEE Explore as well. So we've also been investigating human auditory inspired speech separation. So we humans, we we are blessed with a very an exceptional system in terms of the human auditory system, where we can focus on and attend to a single speech or sound of interest, while other simultaneous sounds are present. So we can focus on a single sound. And we do this by using and utilizing and exploiting multiple cues, including the interaural uh, parameters. That is the interaural, that is the between interaural means oral is ears, inter between the distance between and the time between, the time of difference between the signals that we receive in both our ears. So our ears are separated. We have our head between our ears, and this separation, this distance, which is approximately on average around 0.17 meters, this develops a time difference of arrival of the signals and a phase difference as well as the level or amplitude difference. And this minute difference between the levels or the amplitudes and the phases of signals that we receive in both our ears, we humans, together with some part of the brain, we are able to localize sounds, recognize different sounds, even if our eyes are closed. So we humans are very expert and adept in this, in terms of this skill. And we, as computer scientists and engineers, we want to develop machines or computers have uh, that have this intelligence of and the ability of separating separating a source or sound of interest and separating it from other competing sounds or other noise sound sources. So uh, so we developed some novel methodologies where we where we focused on some statistical models, for example, modeling the way humans separate or focus on these sounds of interest. So modeling them using statistical models in combination with some trained models, some trained deep learning models, specifically UNets, where we train the networks on sounds located at certain locations within a room environment or an enclosure. So if the system learns where a certain sound is located, it learns the interoral parameters of that sound and that location. And it is this learning assisted with the statistical models of the ILD, which is the interaural level difference, and the IPD, which is the interaural phase difference. They provide an enhanced mechanism of separating speech sources. So if speech or sound sources are mixed together, and you want to separate individual speech sources out of the mixture, so such methodologies provide a great deal of advantage. So we developed some novel methods where we got very interesting results compared to some very leading methodologies developed in developed world, including the US and the UK. We published some of our results in some journals, including two or three, I think three of them in Applied Acoustics, which is a very prestigious journal. So we are still working on this. So this most of this work was led by a PhD researcher, Sania Gul. She recently graduated and publishing some in terms of great results and findings during her PhD. So I think she generated around 8 articles during her PhD. 5 of them are published, and I think some of them, 3 of them, are going revisions and getting reviews from journals. Very recently, I think last month or two, we started this work together with some researchers, cancer researchers within the Khyber Medical University, where we are focusing on the invasive ductal carcinoma H&E slides, where pathologists score these slides, and the scores we are focusing on. So these are basically 3 MPhil researchers and they're pathologists as well, and each one is focusing on different scoring these slides through a different technique. This specific one is the Klintrop-Mackinnon score of these slides, pathology slides, and specifically invasive ductal carcinoma H&E slides. So we wanted to compare how pathologists score these slides based on the severity of the cancer, these breast cancer slides. We also wanted to develop an AI-based system where it is trained, on a certain data set, and we wanted to compare how well would this AI model perform in comparison with a pathologist. So this is a study that we recently started. So these are very preliminary results. These are very interesting. So I just wanted to share here on this forum as well. So the Klintrop-Mackinnon or KM score of the invasive ductal carcinoma H&D slides. So we wanted to interpret them using by pathologists and also using the AI algorithm that we developed. So we are now in the process of generating the data as well as scoring them, and also we've developed some preliminary models. So for example, if there are no inflammatory cells within the slide, so they score them. The KM score is 0, and if there is no necrosis, is 1. Mild necrosis is score 2, and increased necrosis is score 3. These are some of the scores, and with some initial pipelines developed, processing these slides and extracting some representative features and running some deep learning models, we wanted to predict these scores based on unseen data after we've trained the models. We With the limited data that we developed together with the pathologists, we ran some preliminary experiments, and we were very encouraged in terms of that we all the in terms of the AI model correctly classified all the images by correctly scoring them in terms of with the with the learning that they had done from the training images. So some preliminary results very encouraging. We are still in the process of developing in terms of more robust, more refined, and some sophisticated uh, methodologies where we can try to compare the AI models predictions compared to pathologists, or at least provide a support system where they can do some repetitive and simple tasks sooner with such decision support systems. I think 40 minutes are over, and I'm just on time. So this is the last slide. I'll conclude in terms of some takeaways. So AI, it is helping healthcare improve clinically, operationally, and financially. So it has a great impact on all these different dimensions, and it must be, this must be exploited. So specifically for the student participants, including the bachelor's, undergrad students, masters researchers, and the PhD researchers, if you're all listening now, so please, work hard and develop your skill set in these emerging fields, including AI and data analytics, and applied AI specifically. So there are plenty of job opportunities, and there are plenty of scholarship opportunities for you in the market. So, just don't, you know, uh, do the conventional degrees or wait, to attend your classes and get some GPAs, but rather side by side develop your skill set in terms of learn the software tools, learn the different programming environments where these algorithms are developed. Start off with machine learning and deep learning. Develop your skill set. Get your hands dirty with coding, and very soon you'll become a valuable person where you can then, in terms of, as they say, sell yourself in the market, and you can get some good opportunities. Uh, uh, in terms of so there is a need to also develop, I'd also conclude that there is a need to develop strong, very strong multidisciplinary teams where you've got engineers, computer scientists, and as I mentioned, the specialist doctors if you're working within this domain. So a multidisciplinary team solving a problem where everybody contributes and develop a very robust solution. And mostly we find that doctors, they're quite busy with their clinics and their routines. So it is very difficult to get hold of them. So we need to have incentives for them. Some we write some joint papers, and we try to incentivize work to bring in the different people from different disciplines to work with us. Uh, there is this work is going to have a significant socio-economic impact, and the ultimate objective and the outcome would be that there is better and cheaper healthcare for all, from wherever they are in terms of geography and economically. So we want to have better and cheaper healthcare for all. This kind of work, applied AI in healthcare, is also going to, you know, uh, in terms of enhance the knowledge base, and you know uh, commercializing these technologies are going to aid in improving the economy by creating jobs and employment opportunities for the young. Also, this work provides a training platform for young graduates and researchers who can improve and further improve their skill set, and move further on the ladder towards getting expertise in these areas. So I think this is it for this is it. I mean, thank you very much for this opportunity to speak here. If we're always happy to collaborate and share knowledge. Uh, if there are any questions or comments, you can definitely ask now or comment now, or if you want to, you know, email. So this is my email. So Shahram, I think.
Yes, thank you very much, Dr. Salman. That was a very comprehensive presentation on the different applications of AI that could be used in healthcare from early detection of ailments to checking health through wearable devices now to improve decision making. So I'm really glad to hear that you're working on a stream of different sort of avenues in healthcare. It's very refreshing to see. We do have some questions. If you don't mind, I'll just quickly put them up here. Okay, so Arsalan is asking about the training set for the phonogram classification. How big was the training set and which libraries were used?
Yeah, so you've got to see the paper, as I really don't remember the numbers. We've got plenty of work going on. We've got over 10 masters researchers and three PhD researchers with other members. So I really don't remember the numbers. The PhysioNet data set that we use for the phonocardiogram, it has a fixed number. I think it's over 4,000 uh, heart sound signals. The Pascal is a subset of it. Basically, I think we only have just under 1,000, as if I remember correctly. So altogether, you can say there are around 5,000 plus signals. Uh, I need to see the paper as well. How much of these signals are are normal and how many of them are abnormal. And we have explored methodologies where we remove this imbalance between the normal and the abnormal data sets. We've also explored multiple methodologies where we validate using different uh, training and validation and test sets. So I really need to check the papers because we've got like three papers published in this area. So each one, of course, explore a different methodology. I can definitely, if you send me an email, I can share the PDFs of the papers where you can find the numbers and the details there.
Great, thank you very much. We have another one from Ibrar. How did you capture the images from the pathology slides? Were these whole slide images or just parts?
Yeah, so basically, these pathology slides were they were scanned and they were digitized, and then of course they were pre-processed. There was a lot of there were a lot of in terms of as you mentioned, they are not the whole slide, so you've got unnecessary data also within the image. So we focused on and zoomed on the information that we required to do some accurate classification of thalassemia and non or detection of thalassemia and non-thalassemia. So yes, they were scanned and uh, they were pre-processed. There are plenty of. I hope that paper is published soon, so it will be online. I cannot share it right now because it is in review now. It has been a few months now. I hope it comes out soon, so it will be available online, and then you can see the methodology. But yes, generally there is a lot of pre-processing. There is standardization of the image in terms of digitally, uh, and then you mentioned how can you predict the slide level. The slide level, what do you mean by slide level labels on these patches?
I think what he
Um,
means is if they're pieces of the same slide, how do you stitch it together to get a whole
no,
slide sort of image?
no, it's basically, yeah. So the thalassemia one, okay. So you're not talking about this. I'm sorry. So yeah, they are not talking about the thalassemia one, but rather the other the breast
The-
cancer slides.
yeah,
Yeah. So yeah. So this is very interesting question. Yes. Uh, so there are multiple layers of doing what we are doing currently, and we are developing. This is an ongoing research. So what I shared is something that we are actively investigating right now, but we have divided our methodology into different layers. So in each layer, we focus on a certain, zoom of the lens, the digital microscope. So we are focusing, so because each slide is scored on a different zoom level. So we focus on that, and we are doing classification within each layer at the moment. So it's not like currently a completely end-to-end solution, but rather we are focusing on one slide and one picture at a time, and then we are going to patch it together. So this is something that this research is ongoing, and we are developing some methodologies for it.
great. Another on the same area, which model, which mode is used for scanning these histopath images, and how much time does it take to scan one slide? I know उसके PCS में scan होता है, so they want to know how much time it takes to scan one slide.
Yeah,
So the
so I need to check that with the time. I need to check that, so I cannot give you an accurate number. This is something that the pathologists are doing together with the researchers. I have not exactly uh, asked about this specific question, and as I mentioned, it is ongoing. So things are very new for us as well. So I'll not be able to comment on this at the moment. But later on, once I've asked, or we've also developed some methodologies. I'll be able to share some numbers and some possibly some reports as well.
great, that'll be very nice. We'll just try and take one more, Dr. Sab, if that's okay. So
Sure.
this one's about thalassemia. How much can we trust AI for genetic abnormality prediction in thalassemia?
Yeah, so this is a very, it's an ongoing discussion in terms of the how, how AI models, their performance and their deployment within a clinical environment or a lab environment as diagnostic systems, and also, in terms of how explainable these AI models are. So there are plenty of perspectives of this discussion. Uh, if I can just comment in terms of that, our work initially is focusing on screening for thalassemia. So screening is kind of a loose word where we are not diagnosing, but we are detecting thalassemia or non-thalassemia. So it's a relatively the first layer problem where you screen the entire population and you separate the ones that you suspect have thalassemia. And there is some freedom in terms of there is some in terms of advantage where the sensitivity, even if it is it has to be sensitive, of course, but specificity, there is some relaxations. Also, uh, we are developing decision support systems. So these are assistive tools. Uh, so we are going to assist. There are many repetitive tasks, or you could say simple tasks that the specialist doctors or clinicians, they have to perform every day. They're overburdened, and these simple or repetitive tasks could be, AI could be used to do these tasks, and so so a system where it is completely AI based, uh, the trust. And so we've not gone onto a level where we've developed a system and we completely rely. There's no other human supervision or feedback, but or confirmation of the results of the outcome of the AI. So we are doing screening through AI. We are doing in terms of developing assistive tools using AI, and at the moment we want uh, our AI's outcome to be confirmed by a human specialist, by a specialist doctor. So, in summary, my answer is that in case of thalassemia, what we are doing is screening, and yes, if we are able to get a sensitivity of over 95%, you can trust the result. And of course, we would want uh, expert hematologists or pathologists to also comment on these or confirm these results.
Great. So, Dr. Salman, we've got a lot of interest from our audience. There's because you've touched so many different fields of the potential of research. So we got just one more. If you can quickly take it, this is by Dr. Rida. So she wants to know, okay, human error. There's a mechanical check. What would be the check mechanism for the AI error? And also she's spoken about the fault detection one, which was very interesting. It also got me excited. So what's the rationale behind the fault detection study? Is it I think what she means to say is कि ये older population के लिए है या epileptic patients के लिए होगा या फिर disabled people के लिए है? What's the idea behind it?
Yeah, so basically, I'll answer the first one. I'll comment on rather. So, so, the AI models or the decision support systems, there are objective metrics. So, for example, as you mentioned, the human errors are also measured by, so you measure it. There is a ground truth, for example, or there are senior expert doctors or supervisors who identify these errors. So in the same way, there are different metrics, and these metrics are objective, computer-based mathematical metrics, where you can evaluate the accuracy and sensitivity, specificity of these AI models. So within the different domains, of, as I mentioned, specialties, these signals that are classified, or the AI provides a prediction on a certain input, you can measure them in terms of if the ground truth is available, if it is available, and you can, through these objective or computer-based metrics, you can identify. And explainable AI is another, in terms of direction we started to explore, where you can explain the AI models of how well it has done and why it has done. The second one I'll comment is, yes, so mainly our work was focusing on uh, the older population, which in the West is very common. They live alone. The old man or the woman, or the old couple, the kids, they go, they leave their parents, and this population, there are millions of them. They fall, they either die or they hurt themselves seriously. So there is a lot of work going on automatic, and there are sound-based detection systems, there are vision-based systems, there are multimodal methods, there are wearable devices. There is plenty of work. But also, as you mentioned, Shahram, that yes, there are, for example, epilepsy or other in terms of diseases, or in terms of human conditions, they could be deployed with them. So it's just human fall detection, and the fall could occur due to old age or any other disease.
Great, thank you very much, and very interesting. Our team's really excited for future collaborations, and we'll also like to extend our invitation to you to come visit us at our lab at RMI and see some of the work that we're also doing around cancer in general, and then other areas as well. So thank you very much
Absolutely.
for your time.
Yeah, thank you very much to you, Shahram, and also Dr. Faisal. Please pass on my regards to him. I'll definitely, inshallah, visit him. I've had some initial discussions with him. It was, I think, last year. We couldn't catch up. He's also very busy, but inshallah, definitely I'll visit, and we'll, discuss some potential collaborations.
Definitely. Thank you very much once again for your time, Dr. Salman, and have a good day.
Thank you very much, Shahram. Thank you. Thank you to all the
Thank you.
participants as well. Thank you.
All right. Allah Hafiz.
Allah Hafiz.